Today, we're going to follow the incredible journey of just a single piece of code. I mean, from the second a developer hits save, all the way to it running live in the cloud. It's a trip, let me tell you, and it's filled with automation, quality checks, and yeah, the occasional inevitable hiccup. Have you ever really thought about that? It's not magic, that's for sure. It's more like a highly sophisticated modern-day assembly line. So the real question is, how do we build, test, and deploy software reliably and, at scale? Well, let's dive in and find out. Every great structure, right, it starts with a solid blueprint. And in the world of software delivery, that blueprint means creating a reusable and consistent foundation for all of our automation, from building and testing to deploying our code. And here is a pain point I am sure so many of you have felt. I know I have. You've got dozens, maybe hundreds of projects, and every single one has a pipeline file that's just a slight variation of the others. So a bug in one means you have to go fix it everywhere. It is an absolute maintenance nightmare. So this is where we apply that classic principle. DRY, don't repeat yourself. With something like Jenkins shared libraries, you can centralize all that common pipeline logic into one single version-controlled repository. So now, when you need to update a deployment step, you just do it in one place, and boom, every single project benefits instantly. Okay, so with our blueprint in place, the code now enters the assembly line. This is where it gets transformed from, raw materials into a finished product that's ready to be shipped out to our users. The very first step, before we build anything new, is to clean up the old. The mvn clean command is absolutely crucial. It deletes all the artifacts from the previous build, making sure we're starting with a completely fresh slate, no leftovers. Next up, the main event, mvn package. This is the command that takes all our freshly compiled Java code and packages it up into a nice distributable format, like a jar or a WAR file. And if you're not familiar, just think of these as special zip files that have all the code and resources needed to actually run our application. This one file is our artifact. It's the self-contained unit we'll be shipping through the rest of the pipeline. So once you've built this thing, this artifact, where do you put it? I mean, you can't just leave it sitting on the build server, right? No way. You need a centralized library, what we call an artifact repository. This thing acts as the single source of truth for every version of every component you build. And a really popular choice for this is JFrog Artifactory. It's incredibly versatile. It's not just for Java artifacts, it can handle Docker images, Python packages, NPM modules, you name it. Plus, it integrates tightly with your CI server and gives you all the security and control you need in a professional environment. Okay, our artifact is built and it's stored. But before it can move any further, it has to pass a pretty rigorous quality inspection. It's kind of like a bouncer at a club, making sure only the best code gets through. This is where we automate our triggers and quality gates to catch issues early. First things first, you have to make sure the pipeline actually runs. And here's a classic mistake you see in GitHub Actions. The trigger is set up to only run on pushes to the main branch. So developer pushes their new feature branch, and crickets. Nothing happens. The fix, luckily, is simple. You just use a wildcard pattern to make sure the pipeline triggers for all those feature branches too. So once the pipeline is actually running, one of the very first quality gates it hits is static analysis. Think of it like a spell checker for your code, but instead of typos, it's finding critical bugs and security vulnerabilities. I mean, it can spot something like a potential SQL injection vulnerability that could compromise your entire database. It's really our first line of defense. And this chart just brilliantly illustrates the power of static analysis. As you can see, it's not just finding simple style issues. It's uncovering major security vulnerabilities, it's flagging overly complex code that's going to be a nightmare to maintain, it's spotting common bugs, and it's even finding dead code that's just cluttering up the place. Of course, even with the best quality checks in the world, no developer journey is perfect. Let's be real. Builds break. So what happens when our pipeline hits a snag? Let's take a look at how we can troubleshoot some of the most common problems. The classic phrase, but it works on my machine. We've all said it, right? We've all been there. When this happens, it's almost always an environment difference. The key is to have a structured approach. Start with the CI logs, then try to reproduce the failure in a clean CI-like environment, maybe a Docker container. Compare everything, from the Java version to the environment variables. Okay, here's another common pain. Your pipeline, it used to take a pretty respectable 7 minutes. Now, 6 months later, it's taking a painful 19 minutes. This slow degradation, it can absolutely kill developer productivity. So how do you fix a slow pipeline? Well, the fix starts with measurement. You got to find out which stage is the bottleneck. A lot of the time, the culprit is re-downloading dependencies on every single run. Caching those dependencies is a huge win. For example, instead of pulling everything from the internet every single time, you can store them locally on the build agent and only download what's new. That alone can slash minutes off your build time.
And what about when a build fails right at the start because it can't download its dependencies? The HTTP error codes are your guide. Think of them as clues. A 401 unauthorized means your credentials are bad, maybe an expired token. A 403 forbidden means you have valid credentials but not the right permissions to access that specific artifact. And a 404 not found is simple. The thing you're looking for, it just isn't there.
Okay, our code has been built, it's been tested, and it's passed all the checks. It feels like we've run a marathon, and now we're at the final mile, deployment to production. But trust me, the challenges aren't over yet. This right here is the scenario that keeps engineers up at night. The pipeline is green, the deployment succeeds, but the app is totally broken for your users. The absolute first priority is to stop the bleeding, roll back to the last known good version immediately. Then, and only then, the investigation begins. Check the logs, check the metrics, and compare the production environment against staging. In modern GitOps tools like Argo CD, you can run into this really strange phenomenon. The tool reports that your application is out of sync, but you check Git and nothing's changed. So what's going on? Well, think of it like this. Git is your architectural blueprint, and your live application is the actual building. If someone makes a change to the building without updating the blueprint, the two are no longer in sync. So why does this drift even happen? It can be for a ton of reasons. As you can see here, someone might have made a quick fix directly in the cluster using kube control. Or maybe an autoscaler checked in and scaled up your application, which is a totally valid change, but it doesn't live in Git. The key is to identify these sources of drift and decide whether you want to ignore them or bring them back under Git's control. And that brings us to our final thought. We've journeyed through the entire technical pipeline. We have the tools, we have the automation, the checks, the whole shebang. But look, having a great pipeline is one thing. Having a team culture that actually trusts that automation, that embraces small, frequent releases, and that takes collective ownership of production, that's the real challenge. So I'll leave you with this. What's one thing you can do to improve your team's culture and get closer to true continuous delivery?